Dear student, in today's lecture we start properties of stationary waves. So first property is stationary waves produced by two identical progressive wave traveling through a medium along same path but in opposite direction. Second property is when stationary wave is produced on string, some point on the string are motionless and these points are called as nodes, or the point where the particle vibrate with minimum amplitude is the node. And some moves with greater amplitude, they are called as antinode, means where the particle vibrate with larger amplitude is the antinode. In last lecture we already seen nodes and antinode in a diagram. Distance between two consecutive nodes or antinode is lambda by 2, that we already proved in the last article. And between node and antinode is lambda by 4. Point between nodes and antinodes move with an amplitude from 0 to a. Between node to antinode, amplitude increases. It starts from 0 and till antinode it is a. Though all particles possess energy except those with nodes, there is no propagation of energy. So this wave is a stationary wave, so not transfer energy from one point to another point because it is a stationary, or it is called as localized wave. Velocity of this wave is 0. All the particles between adjacent nodes, means particle in a loop basically, vibrate in same phase, means they have a same phase, means in a loop all the particle having same state of vibration. There is no change of phase from one particle to another particle, means they having same phase. But when we are talking about the adjacent loop particle having opposite phase as compared to the nearing loop. Now let me learn the difference between stationary wave and progressive wave. Stationary wave we learn, progressive wave everybody know. We already covered progressive wave in the 11th standard also. Now stationary wave remains localized, it is stationary, but the progressive wave is continuously travel continuously in given direction. Second point of distinguish is stationary wave does not transfer energy through a medium because it is stationary, so it does not transfer energy. Progressive wave, it transfer energy from one place to another place through a medium. Nodes and antinodes are formed in a medium. In case of stationary wave, nodes and antinodes are there. In case of progressive wave, when we are talking about transverse progressive wave, it has crest trough. When we are talking about longitudinal progressive wave, it has compression and rarefaction. Amplitude is different for different particle in stationary wave. In progressive wave, amplitude is same for all the particles. All particles in one loop have same phase in stationary wave. In progressive wave, the phase is different for different particle. Now next article we have to cover, and it is Overton and harmonic. Now what is harmonic? So whenever a string or air column is set into vibration, the vibration consists of fundamental frequency, means the basic frequency, the minimum frequency with which it vibrates is the fundamental. And some higher frequencies are there. The minimum frequency is called as fundamental or first harmonic. The term harmonic is used to indicate the fundamental frequency and its integral multiple. So in simple word, harmonic means a fundamental frequency and all its integral multiple. You note this point. Harmonic means fundamental frequency, all its integral multiple of fundamental frequency are called as harmonic. Then the fundamental frequency or first harmonic is denoted by n. Now if it is 2n, so 2 into n, so second harmonic it is called as, so 4n means fourth harmonic. If it is coming 6, then it is called as sixth harmonic. So they are the even harmonic, 2, 4, 6. So we can say that these are the even harmonics. 3n means it is third harmonic, 5n fifth harmonic, 7n seventh harmonic. They are the odd harmonics. So I hope everyone understood harmonic means what? Integral multiple of fundamental frequency. If one means one is coming with the n, first harmonic, or it is fundamental. Two is coming with n, second harmonic. Then three, third harmonic. Harmonic may be present in given sound or not. Harmonic may be there or may not be there. It depends how the air column or how the string vibrate. Now overtone. Overtone is used to indicate only those multiple of fundamental frequency which are actually present. Note this, which are actually present, they are the overtone. Means if this string vibrate n, then 2n, 4n, 6n, then after this n, 2n is coming, so 2n is the first overtone. Then after 2n, if 4n is coming, the 4n is the second overtone, and then 6n coming, third overtone, and so on. Whatever present, they are called as overtone. If they are present, they are called as overtone. But here you note this one. Harmonic may be present or may not be present, but overtone means which are actually present, they are called as overtone. If after n directly 5n is coming, then 5n is the first overtone. Then 10n is coming, then 10n is the second overtone. First frequency higher than fundamental is first overtone. The next, the second overtone, and so on. So you can see here the modes of vibration of string. Here this is the fundamental mode. So here two loops we are getting. So it is called as second harmonic, means 2n we are getting. So it is called as second harmonic, and it is present actually. So it is the first overtone. It is third three loop, third harmonic, second overtone, and so on. Now next article is the end correction. What is end correction? Now you can see end correction in a diagram. So when the pipe open at both the end, and this is pipe close at one end. When it is open at both the end, so this is open end. So here this antinode is formed just above the open end of the tube. Then the distance between this antinode and the edge of the pipe is called as end correction, which is represented by E. You can see E in a diagram. Now pipe is open at both the end. So for this case, so this antinode is above this, means here below this end. So this distance is called as end correction. In case of pipe open at both the end correction is E and E, 2E, because two ends are open. Now, but pipe close at one end. When it is closed at one end, at open end only antinode is formed, and it is formed just above the end of the tube. And that distance is the end correction. Now here, I hope everyone understood what is the end correction. The distance between, you can see here, the distance between open end of the pipe and the position of antinode is called as end correction. The formula for the end correction is E is 0.3 times diameter of the tube. If the tube having a diameter small d, then 0.3 times the diameter is the end correction. Now for pipe close at one end correction is E only. But for pipe open at both the end correction is 2E. Now here, for pipe open at one end and close at one end, we can write total length of the pipe is equal to, we are considering this is a total length. Total length we can write small l and plus this end correction, small l plus E. For pipe open at both the end, the corrected length we can say that. So this small l plus E, small e plus 2E. So this is the total length of this pipe open at both the end. I hope everyone understood what is end correction.